Thank you, Sibyl. First of all, I would like to thank the organizers for the invitation to take part in this conference. I will talk about M cluster filtered algebras arising for a quiver of type EP. Okay. This is a joint work with Natalia Bordino and Ulises Pallero, which is my PhD student at Universidad Nacional de Mar del Plata. In this talk, we are going to discuss M cluster filtered algebras of type EP. In particular, we will concentrate in the case E6. Following Thomas, we recall the cluster category is the overall category of the derived category of the module of the Spanish generated module of the hereditary algebra by the functor time minus shift m, where tau is an underrated translation. And we consider the fundamental domain of this orbit category. We recall that T tilde is an M-cluster filtered object that it has not a positive extension from 1 to m, and the number of the composable class of summas of T is equal to the number of simple elements. And if we consider the endomorphic ring of this M-cluster filtered algebra, we get an algebra that we call an M-cluster filtered algebra arising for a quiver of type Q, where H is KQ. When m is equal to 1, these are the usual cluster filtered algebras introduced by one Marshall rate. And we recall that a complex T in the derived category is silting if there are not positive extension, and the number of the composable summand is equal to the number of simple elements. And T is tilting if also there are not negative extensions. Then Thomas and Reiten have shown that there exists a correspondence between silting complex in the fundamental domain and M-cluster tilting object in the orbit category. If we have a silting complex in the fundamental domain and we take its class in the orbit category, this is an M-cluster tilting object. And if we take an M-cluster tilting object, there exists a representative of this in the silting, and this is a silting complex in the fundamental domain. We consider the hereditary algebra E6 and m equal 2 and m equal 3, because we are going to look at the 2-cluster tilted algebra and 3-cluster tilted algebra. Well, Ulises Pallero has developed an algorithm to compute all the silting complex in the fundamental domain. This algorithm works for EP and for every translation quiver having an additive function. Well, using this algorithm, we get a complete list of all 1, 2, 3 cluster tilted algebra arising for a quiver of type E6. And the question is why we stop in 3? Well, the definition, we are going to say that a cluster tilted algebra is of tilting type if it is the endomorphic ring of a tilting complex, has no positive extension and no negative extension. And then we prove that for M-cluster tilted algebra of tilting type arising for a quiver of type EC, these are given by the 1, 2, and 3 cluster tilted algebra. There are no more. And here we prove formally that. But if we consider an M-cluster tilted algebra which is not of tilting type, if we increase the M, we don't get new algebras. That it seems that the 1, 2, and 3 cluster tilted algebras are all the M-cluster tilted algebras, but we don't have a formal proof yet for tilting complex. Well, some remarks with this. If you consider the non-connected 2 and 3 cluster tilted algebras, we have that they are direct products of the M-cluster tilted algebras arising for a quiver of type A or of type D. Also, this is the direct product of M-cluster tilted algebras, but from different quiver, A and D. And It was already known that the quiver Q for M-cluster tilted algebras is not well defined. There are M-cluster tilted algebras which arise from a quiver of type A or A tilde. This was first shown by Viviana Gubitosi in her PhD thesis. And in our joint work with Fernandez and Garcia Elsener, we developed a lot of examples and analysis problems. Here we show examples of M-cluster tilted algebras arising from linking quivers of different types. The same cluster tilted algebra, M-cluster tilted algebra can arise from two different kinds of quiver linking. For example, A6 and A, A6 and D. And also we get A6 and D and tilde. Then the representation type here also is different, could be different. That is a big difference with one cluster tilted algebras. For example, we have this algebra. This algebra is a two-cluster tilted algebra arising from a quiver of type E6, one of the list. And also it's a five-cluster tilted algebra arising from a quiver of type A6. Then here we can see one of these examples that is crazy. The quiver is not well defined. And also this example, here we have a two-cluster tilted algebra of type E6. And also it's a four-cluster tilted algebra arising from a quiver of type D6. This is E6 and D6. And also this example, also two-cluster tilted algebra of type E6 and a three-cluster tilted algebras of type D5 tilde. Then the quiver is not well defined. We don't know yet why this happens, but it can arise from different quiver, the same algebra. This is one of the difference. And the other one, if we have the result of Assen, Brastel, and Schiffel. They proved for one cluster tilted algebras that they are given by a trivial extension. They show the relation extension. The algebra A, which is one cluster tilted algebra, is the relation extension of V by the module S2 dual of VB, where V is a tilted algebra. In a joint work with Fernandez and Prati, we proved that if V is a cluster tilted of type Q, arising for a quiver of type Q, we already know that it's not well defined, then B is a trivial extension also, and given by the high relation extension, where the algebra E is an iterated tilted algebra. And here we are taking, we are working with a M-cluster tilted algebra of tilting type. That is an endomorphic ring of a tilting complex. In this case, we get that this is a trivial extension. We now prove the converse of this result, that if B is a higher relation extension, where A is an iterated tilted algebra of type Q, then B is an M-cluster tilted algebra of tilting type arising from a quiver of type Q. And this is the converse of the result of Videlsa and Isabel Prati. And we can ask, when if we have an M-cluster tilted algebra, which is not of tilting type, with a right of a pure silting complex, we can ask if it's still a trivial extension. We don't know if it's a trivial extension, but it's not a trivial extension of this type, of this kind. For example, if we have this quiver, this is a two-cluster tilted algebra of arising from a quiver of type E6, and there's not exist a triangular algebra such that A is the higher relation extension. And here we must cut one arrow of this cycle. If we cut an arrow of the cycle to get the algebra B, we get there's not a good correspondence between the arrows and the dimension of the top of this bimodule. with the arrows that we had to add. Then it could not be a trivial extension. And then we can do it for all possible situations, and this does not happen. Then this algebra is not of the form. We don't know if A is still a trivial extension by another module, but not by this module. Then we finish with question: if the algebra A could be of a higher relation extension. In this case, it's not the case. For in cluster tilted algebra of tilted type is not the case. Okay. Well, that's all. Thank you.